If you ever went to school, you might have heard of a thing called hypernotation. And what hypernotation is basically the general term for addition, multiplication, exponents, and other forms of math that do not involve generally taking away. So, for instance, 2 plus 2 equals 4 is hypernotation. However, this equation right here is very interesting because no matter how you format 2 and 2, you're always going to get 4. So, addition, 2 plus 2 equals 4. We all know that. You know how? That's because we have 2 dots, and then we have another 2 dots. And so what we do is we take these dots, put them together, and now you have 4 dots. There are other ways to see it, but generally speaking, that's the simplest way to think of it. Now, with 2 times 2 equals 4. Actually, wait, no, that's... Sorry, I cut ahead. So 2 times 2 is supposed to be this number this many times. So let's do an easier example. 2 times 3. Now with this, we have the 2 3 times. So it would look like this, or in addition, it would look like this. And that nabs you 6. But that's not what we're looking at today. We are looking at 2 times 2, which means we have one set of 2, and now we have 2 sets of 2's. Count them up. 1, 2, 3, 4. So 2 times 2 is 4. Alright. Should have planned that out better. But anyways, moving on to exponents. Or, as some of you might be more familiar with, squaring. Now, squaring is basically the next step in multiplication, where, again, we're going to use 2 and 3. So this is 2 cubed. And what this means is that we take the 2 and multiply it 3 times. So it would be 2 times 2 times 2. And this is different from 2 plus 2 plus 2 because these combine to make 4. And then we have 4 times 2, which equals, by the way, 4. 2 sets of 4, that equals 8. Alright, we got all this cleared up. Alright, now that I've explained exponents, this would be 2 times 2 again, which equals 2 plus 2, which equals 4. So as you can see, we just went back to 4. Now here's where things start to go outside of what they probably taught you in math class at school, because now we're starting to get into the hypernotation that genuinely starts to exceed reasonable use. Starting with tetration, which is, by the way, what happens when you take the exponent and move it to the left. Now, what exponents are, or what tetration is, I'm sorry, it's the next step. So once again, we're going to use our 2, 3 thing. So this is 2 to the third tetration. What this really means is that we're going to take this 2 and give it the power of 2, and then give that the power of 2 because we're giving 3 powers of 2. So 2 to the power of 2 to the power of 2, which this would be 4 which this turns into 2 to the power of 4, and this is 2 times 2 times 2 times 2, which equals 16. Alright, we got that clear. Now let's go back. Alright, this equals 2 to the power of 2. You starting to see the pattern? We went back to 4. Alright, and don't worry just one bit. We still have one more to go. Alright? Alright. It's time for pentation. That's a terrible 2. I'm gonna redo that. So, we see 2 squared, which is on the top right. 2 to the second tetration, top left. Pentation is on the bottom left. And by the way, if it's on the bottom right, it's not really a math term. It becomes some chemistry stuff, or just a more general science term. I can't think of it right now. But anyways, but long story short, we just don't use that. So anyways, now, once again, the pentation basically just goes further up the ladder. Alright, you've seen my explanation for the rest. Now, here we go. Once again, with 2 and 3, 2 to the third pentation. This means we tetrate 2 3 times. So, 1 tetration, 2 tetration, 3 tetration. Alright. As you could probably foreshadow, this is going to be very, very big. So what this is 2 to the pentation, or to the tetration of 4, because 2 to the second tetration, as we have discussed, is 4. So this would be 2 to the power of 2 to the power of 2 to the power of 2. 4 powers of 2. And this is equivalent to 2 to the power of 2 to the power of 4, which is equal to, my bad, 2 to the power of 16. Now we have 2 to the power of 16. I'm gonna take a quick sec, because I'm not even gonna calculate this on here. Because this is 2 times 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 2. Do I make myself clear? Hopefully I do. Alright, so finally have a calculator ready, so this is going to be 2 to the power of 16, which equals 65,536. If you don't see why they don't teach you any higher hypernotations past exponents in school, this is why. By the time you hit tetration and pentation, you're already hitting hypernotations that aren't even applicable to the real world anymore. And it just goes way out of control really, really quickly. Especially pentation. But we're not looking at numbers that go out of control. We're looking at something that is already out of control but is somehow still confined. Because this is 2 tetrated twice, which is equal to 2 squares of 2, which is equal to 2 multiplied by 2, which is equal to 2 plus 2, which, you guessed it, is equal to 4! You cannot escape this! Alright? You see all of this? We've done so much, and yet we've done basically nothing. Alright, the only thing I did was just teach you certain hypernotations you probably didn't need to use. And by the way, this isn't even it. It doesn't end at pentation. No. There's sextation or heptation, which is actually nearly impossible to put into a notation like this. So we have to use Knuth's up arrow notation, which goes like this, where this is tetration, this is pentation, which turns into this. This is the next in line, which when we put a 2 here, guess what that's gonna equal? That's right, 2 to the second pentation, which is equal to 2 to the second tetration, which is equal to 2 squared, which is equal to 2 times 2, which is equal to 2 plus 2, which is equal to 4. Do you see where I'm getting with this? Okay. Moral of the story. Math.